So we're going to start looking at this topic by just asking a simple question that we instinctively do know the answer to. So if two identical trucks were travelling at the same velocity, but one of the trucks is carrying a load of bricks, which one would be hardest to stop? Well, we instinctively know that if they're travelling at the same velocity, it will be much harder to stop the truck carrying the load of bricks. And the reason for that is because the truck with the load of bricks, even though they both have the same velocity, has a greater mass, which would make it harder to stop. And this idea of mass affecting the way something moves leads us to the idea of momentum. Now, momentum can almost translate as strength of movement, and it relates these three things. Momentum relates mass and velocity to each other. So we know that mass is measured in kilograms in physics typically, and velocity is measured in meters per second, and that gives us, if momentum is mass times velocity, the units of momentum are kilogram meters per second. Not kilogram per meters per second, kilogram meters per second, because we know if we multiply the variables together, then we also multiply the units. And we have another formula triangle. This is another mandatory formula where we can see that momentum, which has the symbol of a P or a rho, velocity and mass are all linked together. So we're going to try a couple of example questions now. So here's our first question. If a cyclist and a car are both travelling at 15 meters per second, which is likely to have the lowest momentum and why? So we can hark back to our formula to answer this question. Momentum equals mass times velocity. So we'll go with that and we'll use that to answer our question, even without numbers. So momentum equals mass times velocity. Now, if both of these vehicles are travelling at 15 meters per second, they both have the same velocity, there's only going to be one defining factor in their momentum, and that is the mass. And we know instinctively that a cyclist is going to have lower mass than a car. So you're going to be timesing 15 by a lower number. So the cyclist is likely to have the lower momentum because it's likely to have the lowest mass. And if they're travelling at the same velocity, momentum is mass times velocity. That gives us the answer to our question. We'll try a calculation question next. And we're going to say, what is the momentum of a 1,000 kilogram car travelling at 15 meters per second? If we go back to our formula, we cover up the one that we want to find out. We're left with mass times velocity. So momentum equals mass times velocity, which equals 1,000 kilograms times 15 meters per second, which gives us a momentum of 15,000 kilogram meters per second. So don't forget your units there. So we'll answer a common second part to this question. If the same car had a momentum of 25,000 kilogram meters per second, how fast is it travelling? Now in this question, we want to calculate velocity. So if you cover up the one that you want to find out, cover up velocity, we can see that we need to do momentum divided by mass. So if we have velocity equals momentum divided by mass, which equals 25,000 divided by 1,000, because it's the same car, remember, then that gives us a velocity of 25 meters per second. So that's all you have to do to calculate velocity. And those are the main types of questions you'll get using that simple momentum formula.